Hey there, welcome back to another video from the Math Doc. We are continuing with our set of videos on various formulas, and we're looking at them within the context of literal equations. If you haven't seen the video on literal equations, you may want to check it out. It's linked to this video. But basically, we're looking at equations that have more than one a variable, and in this case we're looking at three variables. We're looking at distance that we travel, the rate that we travel, which we also called speed or velocity, right? And we're looking at the time it takes us to travel. And when we look at this type of formula, sometimes we want to solve for one of the variables that is explicitly inside the formula. So in this case, the original formula shows us how to calculate the distance, right? If we have r and we have t, if we have our rate or our speed and we have the time, we can find our distance just by solving this right here. But sometimes we want to solve for the rate, or we want to solve for the time, right? So we might have the time it took us and the distance, and we want to find the rate. In that case, we take this formula and we solve for r. So we have d equals r times t. And when we say we want to solve for r, what we're trying to do is we're trying to isolate r. And we can use one of our linear equation tools, namely the division property. We will divide by the time t. So if we divide by t, as we're doing here with the fraction symbol, we basically cancel the t dependence on the right, and we have d over t equals r. So here we've solved for the rate or for the speed, which sometimes is given by the letter s. If we want to solve for time, we basically do something very similar. We have d equals r times t. Here we would like to isolate the the time, and so we divide by the rate, by r, or the speed. So we have d over r equals r over r times t. And the rate cancels on the right, and we just remain with the formula t, the time, equals the distance we traveled divided by the rate or the speed we used. And that is how we isolate every one of these three variables. So now to help us understand this a little better, let's look at an actual word example. So let's look at what we have here. The distance between Jack and George's homes is exactly 10 miles. They would like to meet somewhere in between their homes. Jack can ride his bike at a speed of 15 miles an hour, while George, let's highlight that, while George will run at a pace of 5 miles an hour, right? And the distance is 10 miles. If they leave their homes at the same time, where will they meet, and how long will it take for them to reach that meeting place? Well, let's take this word problem and break it down. Let's do a model. Let's actually draw it. So we'll have Jack's home right here. This is Jack, and let's make a little road there between Jack and George. So this is George's home. And we know that the distance between them, the total distance, is 10 miles, right? We also know their speeds or their rates. So let's write first Jack's information. His rate is 15 miles an hour. And George's rate is 5 miles an hour. So George is running and Jack is riding his bike. So now, assuming that Jack's and George basically take this straight road between them, Jack will start from here and George will start from here, and they will meet at a certain point right there. We don't know what this point is. That's sort of what we have to investigate and calculate, but we know they'll meet at some distance. Now, from both their homes. Now, let's call the distance from Jack's home D1 and the distance from George's home D2, right? What we know is that D1 plus D2, the total distance, is just 10 miles. Okay, so we know that. But how do we know what D1 is and what D2 is? Well, we know that from the distance formula, right? So D1 equals the speed for Jack, which is 15 miles per hour. I'll put that in there, times the time that it takes him to get to this little spot here. On the other hand, D2 equals 5 miles per hour. That's his speed. That's George's speed, times the time it takes him. But since they're leaving at the same time, right, it says that they will leave their homes at the same time. Obviously, they will meet at the same time, right? They'll reach each other at a certain moment. So that time is the same time. We just don't know what this time is. So we don't know how long it'll take. But what we do know is that they will be moving the same amount of time. So George will run the same amount of time that Jack will ride his bike. So we can use that to solve this first equation here for D1 and D2, right? So let's write out this equation in terms of what we know about D1. So we have D1 is just 15 miles per hour times t, and plus D2. D2 is 5 miles per hour times t. That will equal 10 miles, right? Because D1 and D2 here equals 10 miles. They will be meeting somewhere along the line between their two homes. So we have 15t plus 5t. We don't know what t is, but it's the same t. So we can write this as just 20 times t equals 10, right? And then we can use our division property. We can divide by 20 in order to isolate t. So we divide by 20. And what we get is, we get t, because these 20s cancel, equals 10 divided by 20 is exactly half. So they will meet at t equals half. What are our units? Well, we were looking at miles and miles per hour, right? The speed was given, or our rate was given in terms of miles per hour, and our distance was given in units of miles. So the time is given in units of hours. So this just equals half an hour. So it'll take them half an hour to meet. Okay, so they will meet after 1/2 hour. Now, the other question was, where will they meet, right? The question is, what is D1 and what is D2? Well, we can use, again, our formula. Let's move back up here. Remember our formula, that D1 equals 15 times t and D2 equals 5 times t. So D1 equals 15 miles per hour times a half hour, right? Which equals exactly 7.5 miles, right? D2 equals 5 miles per hour, right? D2 is the distance that George traveled, times half, which is just 2.5 miles. So now if we draw our model again, we have here Jack's home and here's George's home. So Jack traveled 7.5 miles from here to here, while George traveled just 2.5 miles. And indeed, 7.5 plus 2.5 equals exactly 10. So we've used the distance formula to solve a problem of these two friends heading out to meet each other at different speeds. So this is the video about the distance formula. There'll be another couple of videos on other formulas. But in the meantime, if this video was helpful, please like. If you have any questions or comment, please include those below. And I look forward to seeing you in our next video.